We have discussion on El Nino Southern Oscillation and their interconnection with shortfall in rainfall produced by southwest monsoon winds in Indian subcontinent. El Nino Southern Oscillation, in short known as ENSO, and this phenomena occurs in tropical southern Pacific. Our entire study is divided into four segments. First segment is on southwest monsoon winds, moisture loading in southwest monsoon winds, and their contribution in annual rainfall of India. Second segment is based on Walker circulation in tropical southern Pacific, positive Indian Ocean dipole in western Indian Ocean. Third segment is based on current and contemporary scenario with El Nino Southern Oscillation in tropical southern Pacific and neutral Indian Ocean dipole. And fourth segment is focusing on how India is going to face challenges emerging out of Western Asian crisis, deficiency in rainfall with southwest monsoon winds, and what are the measures required to take by Government of India to not only survive these two major challenges emerging together and how to sustain agroeconomic growth and development with environmental and ecological sustainability to attain Atmanirbhar Bharat, Viksit Bharat and zero emission in long run. So remember that southwest monsoon winds are source of 80% of annual rainfall of India. And southwest monsoon winds are northward extension of southeast trade winds in summers of India. As midday sun is overhead on Tropic of Cancer during summers of India, ITCZ is shifted northward over Great Plains and Himalaya. Here it is known as an ITCZ, monsoon trough, which is a zone of low pressure. As a consequence, southeast trade winds after crossing equator are deflected right hand side to become southwest monsoon winds, and southwest monsoon winds contributing 80% of annual rainfall of India, and these are the vital for agriculture production and productivity in Kharif agroeconomic season of India. Rainfall produced by southwest monsoon winds in terms of their timely onset, northward advancement, and cloudy and rainy conditions dependent on moisture loading in southwest monsoon winds, and moisture loading in southwest monsoon winds are dependent on presence of warm oceanic surface and inflowing onshore trade winds. Greater is the load of moisture, greater is cloudy and rainy conditions produced by southwest monsoon winds. Now, first we are discussing Indian Ocean dipole and Walker circulation in Western Indian Ocean and tropical Southern Pacific. Let us discuss first Walker circulation. Walker circulation is clockwise atmospheric circulation in tropical Southern Pacific. Its lower tropospheric segment is represented by southeast trade winds. Southeast trade winds flow from Eastern Pacific to Western Pacific in tropical Southern Pacific, and southeast trades drive equatorial currents from Eastern to Western Pacific. Thus, southeast trades with Walker circulation, equatorial currents are source of moisture loading in southwest monsoon winds. Another factor contributing moisture loading is positive Indian Ocean dipole, yeah, warming of oceanic surface in Western Indian Ocean. These two factors combining together are source of overloading of moisture and greater cloudiness and rain in Indian subcontinent. Now let us discuss prevailing condition. Tropical Southern Pacific is under influence of ENSO. Southern oscillation is anti-clockwise atmospheric circulation in Southern Pacific. It is a replacement of Walker circulation. And in lower tropospheric flow of Southern oscillation is represented by equatorial westerlies, which are driving moisture from Western Pacific to Eastern Pacific. With driving moisture, they are also driving counter-equatorial current from Western Pacific to Eastern Pacific. Emergence of warm oceanic surface which is lighter and floating along the coast of Peru and Chile with equatorial westerlies, counter-equatorial currents flowing from Western to Eastern Pacific is known as El Nino and together known as Southern Oscillation, yeah, ENSO. Thus, with ENSO, flow of warm oceanic surface, flow of moisture is away from Indian subcontinent. As flow in the Pacific is from Western to Eastern Pacific, though this flow is away from Indian subcontinent, reducing moisture supply in southwest monsoon winds. Meanwhile, there is neutral Indian Ocean dipole in Western Indian Ocean. So these two have combined together and responsible for delayed onset of southwest monsoon winds and deficiency in cloudiness and rainfall. And according to predictions, depending on geography and time, there are deficiency from 25% to 50%. Some of the areas like Meghalaya are so far experienced 80% of deficiency in rainfall. Now, India is facing twin challenges: deficiency in rainfall produced by southwest monsoon season in Kharif agroeconomic season of India and supply side constraints of crude oil, petroleum and natural gas, rising cost of a very important soil nutrient known as urea due to West Asian crisis. So India is not only required to survive these twin challenges, India is also required to sustain agroeconomic growth and development with environmental and ecological sustainability to attain self-reliance, Viksit Bharat by 2047 and zero emission by 2070. To overcome these challenges and most importantly deficiency in rainfall produced by southwest monsoon season, Government of India is required to take an integrated and holistic measure which could be cited as first, accurate forecasting warning and alert of cloudiness and rainy conditions, yeah, northward advancement of monsoon, deficiency of rainfall, degree and intensity of drought. Second, supporting rainwater harvesting by capturing and collecting water so that local equilibrium could be maintained between demand and supply of water for agroeconomic purposes. Third, replacement of high water intensity crops with low water intensity crops. Low water intensity crops are like millets, pulses, oilseeds. High intensity crops are like paddy, sugarcane, cotton. So, sugarcane, cotton, paddy must be replaced with low water intensity crops so that there could be conservation of water with the conservation of soil too. replacement of monocropping with mixed cropping and intercropping to support again both soil conservation and water conservation, expansion in irrigation footprint, most importantly irrigation expansion in areas irrigated with micro irrigation, with sprinklers, wells and tube wells, drip irrigation so that water could be effectively used, timely compensation to the farmers to maintain capital with them so that they could grow for cultivation into the next season known as Rabi season, which is the winter season crops. And most importantly, in the long run, Government of India is required to take interlinking of river basin, intra-basin interlinkages, inter-basin interlinkages so that water could be transported, could be circulated, could be optimally used from surplus water basins to deficit water basins and could be utilized effectively for agroeconomic purposes, drinking purposes, industrial and urban purposes, infrastructural purposes. Thank you so much.